Welcome back to Global Works TV, where we explore the fascinating world of industrial craftsmanship. Today, we're taking you inside Lour Wood Products, a mill that represents everything great about American woodworking tradition meeting modern efficiency. Now, if you grew up around sawmills, like many of us did, you'll appreciate what Lour has built here. This isn't just another lumber operation. It's a sophisticated facility dedicated to processing oak and producing edge-glued panels that end up in homes and businesses across the country. Oak, as you probably know, has been the backbone of American furniture and construction for generations. It's the same wood that built the great sailing ships of the 1800s and the hardwood floors in those beautiful old Victorian homes. Let's walk through their operation. It all starts with raw oak logs arriving at the facility. These logs are carefully sorted by species, red oak and white oak, because each has distinct characteristics. Red oak has a more prominent grain pattern and slightly pinkish tone, while white oak offers superior water resistance, which is why coopers used it for whiskey barrels for centuries. The initial processing begins at the debarking station. Modern debarkers use rotating drums with hardened steel teeth that strip bark cleanly without damaging the valuable wood underneath. This is crucial because any bark left on the log can damage saw blades and contaminate the final product. The bark itself isn't wasted. It's collected for landscaping mulch or biomass fuel. Next comes the primary breakdown saw, typically a large bandsaw or head rig. This is where the real artistry meets technology. The sawyer, and yes, they still call them that, examines each log and decides how to orient it for the first cut. They're looking at the grain, checking for defects, calculating yield. Modern laser scanning systems assist by creating a 3D map of each log, but experienced sawyers still make the final call. They're cutting these logs into cants and flitches, which are basically squared off sections and thick slabs that'll be processed further. Here's where it gets interesting for those edge-glued panels. After the initial breakdown, the wood moves to edgers, specialized saws that trim the irregular edges to create straight, parallel sides. Then comes the board optimization process. Automated scanners check each board for defects, knots, splits, mineral stains. The computer-controlled trim saws cut out defective sections, maximizing the yield of clear wood needed for premium panels. The boards then enter the kiln drying phase. Oak typically needs to reach 6 to 8% moisture content for interior applications. This can take anywhere from 4 to 8 weeks in conventional kilns, though Lour likely uses vacuum or dehumidification kilns that speed the process. Getting this right is critical. Dry it too fast, and you get checking and warping. Too slow, and you're wasting time and energy. After drying, boards are planed smooth and ripped to consistent widths on high-speed rip saws. Now comes the edge gluing process. The edges are jointed perfectly straight and flat. We're talking tolerances within a few thousandths of an inch. Then these boards are arranged edge to edge, coated with industrial wood adhesive, and clamped in massive panel presses. The pressure has to be distributed evenly across the entire panel, typically around 150 to 250 pounds per square inch. Once the glue cures, these panels are remarkably strong, often stronger than the wood itself. They're then run through wide belt sanders to achieve that smooth, uniform surface. The final panels might be cut to custom sizes, finished with various treatments, or shipped as raw material to furniture makers and cabinet shops. It's a beautiful marriage of old-world wood wisdom and modern precision manufacturing. Now let's travel across the Atlantic to explore something special. Wisa birch plywood production at UPM's facilities in Finland and Estonia. If you've worked with plywood over the years, you know that not all plywood is created equal, and WISA birch plywood is considered the gold standard. Northern birch is unique. Growing in the challenging climate of Scandinavia, these trees develop incredibly tight growth rings, producing dense, strong wood. The Finns have been perfecting plywood manufacturing for over 100 years. They essentially invented modern birch plywood production in the early 1900s. The process at UPM's Savonlinna plant in Finland and Otepää facility in Estonia follows the same meticulous approach. It starts with sustainably harvested birch logs. These logs are debarked and then conditioned, heated in water or steam vats. This conditioning serves two purposes. It softens the wood for peeling and helps reveal any hidden defects. Here's where it gets fascinating. The logs are mounted in massive rotary lathes. Imagine a giant lathe turning at controlled speeds while a knife blade, sharp as a razor and spanning the log's length, peels a continuous veneer ribbon, typically 1.4 to 3.2 millimeters thick. It's like unrolling a carpet of wood. The skill involved in setting the knife angle and pressure is remarkable. These veneer ribbons are clipped to size, and any defects are cut out. Then comes grading and sorting. Veneers are classified by quality, with the clearest, most uniform pieces reserved for face veneers. The veneers then pass through jet dryers, where hot air rapidly reduces moisture content to about 8 to 12%. The layup process is where plywood gets its strength. Veneers are arranged in cross-grain layers, each layer oriented 90 degrees to the one below. This cross-lamination is what gives plywood its dimensional stability and strength in all directions. Adhesive, typically phenol formaldehyde resin for exterior grades, is applied precisely. These layered stacks then go into hot presses operating at temperatures around 280 to 320 degrees Fahrenheit under pressures exceeding 200 psi. The heat cures the adhesive while the pressure ensures perfect bonding. After pressing, panels are trimmed, sanded, and graded. Wisa's reputation comes from this unwavering commitment to quality at every step. Let's head down to New Zealand's Northland region, where they've built something remarkable in forestry and timber processing. This area showcases how modern forestry can be both productive and sustainable. Radiata pine, Pinus radiata, is the star here. Originally from California's central coast, this species found its true home in New Zealand's climate. Planted commercially since the 1920s, radiata pine grows incredibly fast in New Zealand, reaching harvest size in just 25 to 30 years, compared to 60 or more for many Northern Hemisphere species. The journey starts in the forests. Modern harvesting operations use sophisticated equipment, feller bunchers that can grab, cut, and stack multiple trees, and processors that delimb and buck logs to precise lengths right in the forest. These aren't your grandfather's logging operations with axes and crosscut saws. Logs are sorted at the landing by size and quality. The best logs, clear, straight, large diameter, go for structural lumber or veneer. Smaller or lower grade logs might become pulp or engineered wood products. GPS tracking follows each log from forest to mill, ensuring traceability. At the sawmill, logs are debarked and scanned. Computer-optimized sawing systems determine the best cutting pattern for each log, maximizing yield. High-speed bandsaws and circular saws break down logs into cans, which are further processed into dimensional lumber. What makes Northland special is the integration. Many operations handle everything from seedling to finished product. After sawing, lumber is kiln-dried using carefully controlled schedules developed specifically for radiata pine. The wood then might be finger-jointed, short pieces joined end-to-end with interlocking fingers to create longer, more valuable lengths. Some facilities produce engineered products like laminated veneer lumber or cross-laminated timber, taking advantage of radiata pine's workability. The region's investment in modern technology while maintaining sustainable forest practices represents forestry's future. Welcome back to Lour, but this time we're exploring their hardwood specialty division, where they craft beautiful kitchen countertops and island tops. If you've ever dreamed of having a solid hardwood countertop, you'll appreciate the craftsmanship that goes into these pieces. Hardwood countertops have experienced a real renaissance. While granite and quartz dominated for years, folks are rediscovering what our grandparents knew. Nothing beats the warmth and character of real wood in a kitchen. Butcher block countertops, in particular, have roots going back to 19th century European butcher shops, where hard maple was prized for its durability and self-healing properties. Lour works primarily with hard maple, cherry, walnut, and oak for countertops. Each species offers distinct characteristics. Hard maple is the workhorse, incredibly dense, light-colored, and resistant to cutting damage. Walnut brings rich, dark chocolate tones. Cherry develops a beautiful patina over time, darkening to warm reddish hues. White oak offers those classic rays and medullary grain patterns that Americans have loved for centuries. The process demands precision at every step. It starts with selecting kiln-dried lumber, already brought to 6 to 8% moisture content. Moisture consistency is absolutely critical. Mixed moisture content means different expansion rates, which means problems down the road. Each board is inspected and surfaced through planers that remove any irregularities and create uniform thickness. Then comes the ripping process, where boards are cut into strips. For a traditional butcher block, these are typically 1.5 inches wide. For edge grain countertops, strips might be wider, 3 to 4 inches. The orientation matters. Edge grain shows the growth rings on the face, while end grain has the actual ends of the wood fibers facing up. Here's where Lour's expertise shines. Those strips are arranged, considering grain pattern and color matching. This isn't random. Skilled craftsmen arrange pieces to create visual harmony, sometimes book matching or creating intentional contrasts. The edges are then jointed dead straight on industrial jointers. The glue-up is crucial. Modern waterproof adhesives, often polyurethane-based for their water resistance and food safety, are applied to each edge. The strips are then clamped in hydraulic presses. The pressure needs to be substantial but evenly distributed. Too much in one spot and you'll squeeze out all the glue. Too little and you get weak bonds. After the adhesive cures for 24 hours, panels emerge as solid slabs. They're then run through wide belt sanders, progressively finer grits, removing any unevenness and creating that smooth surface. Multiple passes, starting maybe at 80 grit and finishing at 150 or 180 grit, ensure perfection. Shaping comes next. CNC routers or shapers cut the countertops to exact dimensions. They can create curved edges, cut out sink openings, or route drainage grooves. Edge profiling, whether it's a simple eased edge, a Roman ogee, or a custom profile, is done with precision router bits. The final finish is what protects the wood and brings out its beauty. Food-safe mineral oil and beeswax mixtures are traditional and require regular maintenance. Modern options include hardwiring polyurethane or specialized waterlocks finishes that offer better protection while maintaining that warm wood appearance. Each countertop that leaves Lour represents dozens of hours of work and generations of woodworking knowledge applied with modern precision. It's functional art for your home. Our final stop takes us to Budon's Sawmill, a facility that exemplifies efficient lumber processing. Sawmills like Budon have been the economic backbone of timber communities for generations, and while the technology has advanced tremendously, the fundamental mission remains unchanged, transforming logs into usable lumber. Budon's operation handles various species, adapting their processes to each wood type's characteristics. The facility represents modern sawmilling, computer-controlled, efficient, yet still requiring that human expertise that comes from years of experience. The process begins as logs arrive by truck, already measured, and often pre-sorted by species and grade. A log deck stores inventory, with logs organized for efficient processing flow. Modern mills use rotating log decks that feed logs automatically to the debarker, eliminating much of the manual handling that made old-time sawmilling so labor-intensive. The debarking process at Budon likely uses either a ring debarker or a rosser head system. Ring debarkers surround the log with rotating arms tipped with cutting teeth, while rossers use a spinning head that presses against the log. Both efficiently remove bark while minimizing fiber loss. Every bit of wood matters when you're processing thousands of logs. After debarking, logs proceed to the scanning station. This is where modern technology really shines. Laser scanners create detailed 3D models of each log, measuring diameter, taper, sweep, and visible defects. Sophisticated optimization software then calculates the cutting pattern that'll yield the most valuable lumber from that specific log. It's remarkable. These systems make thousands of calculations in seconds, something that would take even an experienced sawyer considerable time. The primary breakdown occurs at the head rig. Budon might use a bandsaw head rig for its thin kerf, the width of cut, which wastes less wood. Alternatively, they might employ a modern circular saw setup. The log is positioned and clamped, then cut according to the optimized pattern. The sawyer monitors the process, ready to intervene if something unexpected appears. As cants and boards come off the head rig, they move to the gang saws or resaws. These cut the cants into multiple boards simultaneously. Modern gang saws can have 20 or more blades spaced precisely apart, essentially slicing a cant into a stack of boards in one pass. Edgers then trim the waney edges, those natural bark-covered edges, creating straight-sided boards. Defects are simultaneously removed. High-speed trim saws cut boards to standard lengths, removing splits, excessive knots, or other defects. This optimization ensures maximum value recovery. Finally, boards are sorted by grade, species, thickness, and length. Automated sorting systems use scanners and mechanical arms to route each board to its designated stack. It's like watching a carefully choreographed dance of wood and machinery. From there, lumber typically goes to stickered stacks for air drying or directly into kilns, but that's another story. What you've witnessed at Budon is the evolution of sawmilling, respect for the resource, efficiency in processing, and that enduring commitment to quality that defines the best mills.